Okay, back with homework number 29. And the concept here is this idea of rationalizing the denominator. Now, what rationalizing the denominator means is that there's only whole numbers in the denominator, not a square root of something like the square root of 45 in the case of number 1. It's the act of getting the denominator to not have a square root in it. A couple things we need to understand about this. One of them being fraction equivalence. And so, let's say we had 3/5. If we multiplied both of these by 7 if we multiplied both the numerator and denominator by 7, we would get 21 over 35. And 3/5 is equivalent. It's the same thing as 21 over 35. So what I'm getting at here is we can multiply both the numerator and the denominator by anything we want, and we still end up with an equivalent fraction. And so it's going to be important in our work today that we understand that. And so again, remembering before I erase this, we can multiply the denominator of a fraction by anything we want, and it will produce an equivalent fraction. How that pertains to our work today is we're going to be first simplifying the radicals as much as we can, and then saying, hey, is there a radical in the denominator? And if there is, we're going to do some work to get it out of the denominator. Let's go ahead with that. We can't simplify the square root of 5 at all, but we can simplify the square root of 45. Square root of 45 is 9 times 5. We've done this one lots. 3 times the square root of 5. So this can be rewritten as the square root of 5 over 3 times the square root of 5. Now it's interesting in this first one because we have a square root of 5 in the numerator, we have a square root of 5 in the denominator. And just like anything in fractions where we have the same thing in the numerator and denominator, those two are going to cancel. What's going to be left in the numerator is a 1. And so this is going to simplify to be 1/3. See how we have no square root symbol in the denominator. We have effectively rationalized the denominator. The process will be a little bit different going forward, but in this case it was kind of easy because the square root symbol and what was inside of it just canceled itself out. Now here with number 2, we have the square root of 63. There's no square root symbol in the denominator, which is nice. 63 has the perfect square 9 as a factor, 9 times 7. So that's going to be 3 times the square root of 7. So we're going to replace 63 with 3 times the square root of 7 plus 9 over 18. And one thing we need to understand is that this part of the fraction and this part of the fraction both share that denominator. So that can be rewritten as 3 times the square root of 7 over 18 plus 9 over 18. Now some canceling will happen. The 3 and the 18 will cancel. That will become a 1. That will become a 6. And the 9 and the 18 will cancel. That will become a 1. That will become a 2. So we end up with the square root of 7 over 6 plus 1/2 as our final answer for this one. I'll leave that there for a moment, and I'm going to move on to number 3. Okay, number 3, we need to rationalize the denominator, which means get the denominator to not have a square root symbol in it. And so, as I mentioned at the beginning of this video, we could multiply the numerator and denominator of this fraction by anything we want. I could multiply the numerator and denominator by 15, and I would still have an equivalent fraction. It does not matter what we do, as long as we do it to both the numerator and the denominator. And so what we want to do is be creative here and pick a number that will make the radical symbol go away. And what we're going to pick is the square root of 3, the exact same thing that's in the denominator. Because if we multiply square root of 3 by square root of 3, we just get 3. And so square root of 5 times square root of 3 is the square root of 15. Square root of 3 times square root of 3 makes 3. And there's no simplifying that we can do because the square root of 15 doesn't have any perfect squares. 15 doesn't have any perfect squares. And so we are done. Again, the big thing to understand here is that we can multiply the numerator and denominator of any fraction by anything we want. And we're going to pick a number on purpose that makes the denominator no longer have a radical symbol in it. Most of the time, it's going to be picking the same number that's in the denominator. Okay, I'll leave that there and move on to number 4. Number 4, we have square root of 3 over, we have the square root of 3 over 7. Now, what we need to understand is that can be rewritten as square root of 3 over square root of 7. Those are equivalent. They are the same thing. And now, just like number 3, we can multiply by something to make the radical symbol go away in the denominator. And it just happens to be the exact same thing that's already there, the square root of 7. So our denominator now is going to be just straight up 7. I don't know why that's not showing up on my screen yet. There it goes, a little bit of lag. And the numerator, we're going to have 3 times 7 is 21. And there are no factors of 21 that have a perfect square root. So square root of 21 over 7 is going to be our final answer for number 4.